Hi everyone, this is Mrs. GA, and today we're going to learn about the properties of rectangles, rhombuses, and squares. So let's start with the definition of a rectangle. So a rectangle is a quadrilateral with 4 right angles. And remember, a right angle is just a 90-degree angle. So that means all 4 are 90 degrees, and we show it with the little box in the angle. So if a quadrilateral is a rectangle, then it is also a parallelogram. So a rectangle is a more specific type of parallelogram, which it means it has all of the properties that we talked about for parallelograms. So since it has those properties, let's go in and mark what those are. Again, the properties of a parallelogram are that the opposite sides are parallel. We also know that that means that the opposite sides are congruent. And last thing we know is that that means that the diagonals bisect each other, meaning this is congruent to this and this is congruent to this. So I'm using a separate color to show that set of congruency. So again, since a rectangle is a type of parallelogram, it kind of absorbs those properties that we talked about for parallelograms, in addition to having 4 90-degree angles. So another new property of a rectangle that a parallelogram does not have is that the diagonals are actually congruent. So in addition to bisecting each other, we can also say that the diagonals are congruent. So if they're congruent, that means that all 4 of these are equal, because the entire thing is equal, so their halves are also equal. So again, this is a property that is new for rectangles, does not work for parallelograms. Okay, so this is a new property for rectangles. So now let's talk about the definition of a rhombus. So a rhombus is a quadrilateral with 4 congruent sides. So that means all 4 sides are the same length. So notice that in this one, it does not have that property that we talked about for a rectangle. Notice the angles are not all 90-degree angles. But it does have 4 congruent sides. So a slightly different type of parallelogram. So similarly, since a rhombus is a type of parallelogram, it absorbs all of those features that we talked about. So we know that the opposite sides are parallel. And we also know that the diagonals bisect each other, meaning these 2 segments are congruent and these 2 segments are congruent. So it takes all of the properties from parallelograms, but it adds that new property that all 4 sides are the same length. In addition, we also have another property that is unique to a rhombus, and that new property is that the diagonals are perpendicular, meaning when they cross, they form a 90-degree angle. So all 4 of these angles are 90 degrees. So putting those 2 things together, since a rhombus has diagonals that are perpendicular, and since a rhombus is still a parallelogram, we can state that the diagonals are actually perpendicular bisectors, which again, they make a 90-degree angle and they cut each other in half. So again, the bisector part came from the fact that it is still a type of parallelogram, and then the perpendicular part came from that unique feature of a rhombus. Okay, and now let's move on to the definition of a square, which is the most specific type of quadrilateral. So a square is a quadrilateral with 4 right angles. So that comes from being a type of rectangle, but it also is going to have 4 congruent sides. So you can see that it kind of took all of the features from the previous parallelograms we've talked about. So it took the right angles from the rectangle and it took the congruent sides from the rhombus. So squares have all of the properties of a rhombus and a rectangle. And of course, both of these have all of the properties of a parallelogram. So just to be extra clear, a rectangle is a type of parallelogram. A rhombus is another type of parallelogram. A square can be a type of rhombus, a type of rectangle, or a type of parallelogram. It falls into all three, and it takes all of the properties into one. Okay, so now let's try a couple examples together. So in example 1, just right off the bat, by looking at quadrilateral ABCD, because it has 4 right angles, we know that this is a rectangle. So because it has 4 right angles, we can confirm that this is a rectangle. So the given information is that side length AB is 15 centimeters, BC is 11.25 centimeters, and they would like us to find DB. So since it's a rectangle, there's a few different things we know. One thing we know is that the diagonals are congruent. So we actually know that DB is equal to AC. The two diagonals are actually the same. And that means that since DB is what we're finding, if we find AC, it's going to be the same as our answer. So look at this right triangle that I have here. So using AC, and we know this is 15 and we know this is 11.25, we can actually use the Pythagorean theorem, which is A squared plus B squared equals C squared, to help us find this diagonal. So that will be 15 squared plus 11.25 squared equals C squared. So C is going to be the square root of 15 squared plus 11.25 squared. And then this you can plug into your calculator. And we get 18.75. So that's the length of AC in this case. So since AC is equal to 18.75, we know that DB is also equal to 18.75 centimeters. Another way we could have approached this problem is, well, since we know it's a rectangle, we know that it has all of the properties of a parallelogram, and so for a parallelogram, the opposite sides are congruent. So this is 15, and this is 11.25. And then we could have done the Pythagorean theorem using this as a right triangle. So we could have solved it straight for DB. But either way, it's about the same amount of work. Okay, let's give this last problem a try. So here we're told that the figure below is a rhombus. So remember, we know that the distinguishing feature of a rhombus is that it has 4 congruent sides. So that means that all 4 sides are congruent. Now if you look at the problem, they're asking us to find the measure of angle VXY, which is this angle right here. So we won't really need to use any of the information about the sides for this problem. So it's kind of just extra information that we know these 2 side lengths. So we're going to think about, well, what else do we know about a rhombus? So we know that in a rhombus, the diagonals are always going to be perpendicular bisectors, which means, one, they bisect each other, so they cut each one in half, but more importantly, they form 90-degree angles right here. So since I know this is a 90-degree angle, so I can say angle WZX equals 90 degrees because it's a rhombus. We can say angle WZX equals 3n squared minus 0.75. 0.75. So that means that 90 equals 3n squared minus 0.75. So we can use this to help us solve for n. So here we can add 0.75 to each side, and then divide by 3. And then if we take the square root, notice I'm not doing the plus or minus square root because since it's a polygon, we only want to work within the positive realm. It wouldn't make sense to have a negative angle. So we would get n equals 5.5. So now that we know what n is, that means that we know what angle WVX is, because we know from the figure that it's 9n plus 4. So we can substitute n with 5.5. And here we get 53.5 degrees. So then last we need to look at what we're actually trying to find, which is angle VXY. So luckily we know that a rhombus, of course, is a type of parallelogram, which means the opposite sides are parallel. So using that information, I have two parallel lines cut by a transversal. And then we can see from this, we can make the statement that angle WVX is congruent to angle VXY because they are alternate interior angles. So that means if angle WVX is 53.5, we can conclude that angle VXY is also 53.5 degrees. Okay, that is all for today's video. Thank you so much for watching.